Yo, what's up, guys? Hopefully this works. I'm on my. Oh, that's my roommate. I'm on my Windows part. Here we go. It worked. Okay. On my other hard drive, boot into Windows. We're gonna do this video a little different. We're gonna do one leetcode problem today, and then we're gonna jump into. I've been trying to learn C#. Kind of want to get more in depth with it, so I think that's the goal for today. Probably just gonna look at a simple problem. Take a look at, like, I don't know, some graph problem we haven't done, maybe, I don't know, or maybe some problem here we haven't solved. Search a 2D matrix. Find minimum and rotated minimum array. What is this? Suppose you have an array of length n sorted in ascending order and rotated between 1 and n times. For example, the array nub is equal to this. If it was rotated 4 times, okay, so we're moving everything by 1, right? If it was rotated 7 times, okay, notice that rotating the array 1 time results in the array A. Okay, given the sorted rotated array nums of unique elements, return the minimum element of this array. 1 time results in the array. Given the sorted rotated array nums of unique elements, return the minimum element of this array. So where does the rotation come in this? I don't really. I'm a little confused with this problem. Please don't post sessions. It's said to be minimum in a rotated sorted array. I'm a little confused with the problem. Man, it is hot in my room, dude. I am literally sweating in here. Trying to actually understand the problem. So obviously, like, I know that this is a binary search problem, right? I mean, it was in the binary search section, but the thing is that to do binary search, doesn't the array have to be sorted? I thought, no, right? Like, to do binary search, does array need to be sorted? Yeah, it must be sorted. Yeah, exactly. That's what I thought. Okay. I rotated. We want to find it in log n time, right? Let's write an algorithm that runs in log n time. What's up, Galactic Boss, dude? How you doing, bro? Nice to see you, bro. How's your day? Okay, so technically the array is sorted, right? Because we have one, it's just rotated. But technically it can be sorted. Maybe we'd have to do the binary search from the point that it's rotated at. I don't know. I'm actually not sure, dude. Rotated binary search. Leetcode. Search and rotated array. Find them. I guess we have to copy this. Oh my gosh, dude, I cannot even copy it. Find minimum and rotated sorted array. Rotated sorted array. Okay. Let's take a look at this video because I'm not sure how we apply binary search to this sort of problem.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem find minimum in a rotated sorted array. So we are given an input array of length n that is sorted in ascending order, but it could be rotated 1 to n times. For example, if we have an array like 1, 2, 1, 0, 1, 2, right, to rotate it by 1, basically
Going to right, I've been stuck on.
It means to take the rightmost element,
what problem are you doing, bro?
To the beginning, like
is it a leetcode problem?
Right, so this has been rotated by 1. We could also rotate it by 2 by taking the last 2 elements and moving them to the beginning. So something like this, right? This has been rotated by 2. And so we want to find the minimum value, and we want to do it in log n time, as they say. The good thing is that we do have some kind of sorting property that we can use to our advantage to find this log n time solution, and we are guaranteed that every value in the array happens to be unique. Of course, it would be easy to find a linear time solution, basically just scan through every single value in the array and then take the minimum value and return it, but we can use the sorting property to our advantage even if the array has been rotated. Let me show you how we can do that solution. As you might be able to guess, it is going to involve the binary search algorithm, which is usually the algorithm that runs in log n time. So the fact that the array was originally sorted is what hints to you that binary search might work in this case, but it's not going to be a traditional binary search. Now, of course, if the entire array was rotated n times, that basically means we took a sorted array such as...
Gonna do this, gonna look at this problem and then learn some C++. So
it's not going to be a traditional binary search. Now, of course, if the entire array was rotated n times, that basically means we took a sorted array such as 1, 2, 3, 4, 5, rotated it n times, basically leaving it in the original sorted order. Now, if we had an array that was completely sorted like this one, an easy binary search would work on a sorted array. But if the array is fully sorted, then we know that the minimum value is going to be the leftmost, right? So if
now I'm trying to write my own immediate mode GUI for my project. I'm trying to implement a drop-down menu but can't figure out, and it's driving me nuts. Nice, bro. What tech stack or what do you my own immediate mode GUI? I'm not sure what an immediate mode GUI is, to be honest, but yeah, what are you programming it in? Like what's your stack? I'm just curious.
At any point
that sounds cool,
we
though, dude.
Get a binary search is going to run like this.
I've been trying to learn. I mean, I've only started a couple days ago, but trying to learn C++ with my friend. So probably going to do some C++ after this and play around with it. So
and a right pointer. If we ever get to a point where the entire array is sorted, we can just return the leftmost element, or at least consider this as being the minimum value. So let's try a binary search and see how it's going to be different than a regular binary search. Now, of course, we want to find the minimum value. We're going to initialize our left pointer here and our right pointer here. Basically, the current pointer situation means that we are considering this entire array to find the minimum. The minimum could be from anywhere in this array, and the result is going to be the minimum, and I'm going to keep track of that over here. Now, of course, one way we could do this problem is basically find the pivot, right? Find the position where the elements are not in increasing order, right? From here to here, 3 to 4, they're in increasing order. From 4 to 5, they are in increasing order. From 1 to 2, they're also in increasing order. But from 5 to 1, they're in decreasing order. This is the pivot, right? So basically, this value is going to be the minimum. But I'm going to do it in a slightly different way where we don't necessarily have to, look exactly for the pivot. I'm going to take, left, right, take the half of them, get our middle pointer. Our middle is going to be over here at 5. So I'm going to consider as 5 being the minimum value we have seen so far, right? So our result is going to be 5. Now,
Okay, well, I think I have an idea how to solve this. Let's do our left is equal to 0. Right is equal to the length of nums minus 1. So games, I'm using C++ and Vulkan, which is a graphics API. Hey, let's go, dude. So games, I'm using C++ and Vulkan. That's cool, man. I'm actually going to be doing C++ right after this, bro. I'm literally just about to start learning, dude, so you can help me out. I struggle a lot with the memory stuff and all that, so I'm trying to get my head around like pointers and all that sort of shit. So you can help me out though, dude. After I do this problem, I'm going to I got like a little project. I'm just doing a little linked list project, you know, implementing a linked list pretty much like in C++, but that's the goal. So let's do while left is less than right. Left is less than or equal to right. I want to calculate our mid, right? Mid is equal to. Oh, I just saw you on my feed. What is going on here? Just doing a leetcode problem, Shubi. I don't know. Just try and stay consistent and, you know, program every day and do something I, you know, have a passion and, you know, I just started out doing some leetcode projects and stuff. I figured out how pointers work because of a meme. That's funny, Galactic. That's funny, bro. But yeah, it's just try to stay consistent and kind of document my journey and, yeah. I don't know. I don't really know kind of what it is. That's kind of all it is, you know. So I don't know. Just thought I'd pick up a camera and start recording myself do it. So nothing else to it. Okay, so we calculated our mid here, right? We're looking for the min value, right? So initialize our min value with a float. I don't think I can post links. To be honest, dude, I have no idea if you can post links or not, but if you can, then you're more than welcome to. If not, like, I have Discord in the description if you wanna join the Discord, and you can message me on Discord. I'll put it up on the model next to me. How often do you come live here? Because I also like to feel like I need to start coding again. I'm live every day, bro. Probably the same. After work, I go live for a couple hours, so every day, unless I'm not here. So, then, you know, sometimes I'm just like literally not at my house, so I cannot record a video. So, but every day that I'm here, which is, you know, like I'm not gonna be recording this weekend, Saturday or Sunday, or Friday, because I'm not gonna be here. I'm going out of town. So, but yeah. Okay. So we want to find our min here, right? So we want to find the pivot point, right? So I'm thinking here that we need to kind of modify the binary search. So if we're increasing here, so if our midpoint, if nums, I appreciate that, Galactic. You added me. Let me see. Oh shit, let me open my Discord, bro. Oh, doesn't open. Nice. What's going on here? Yeah, just message it. You can private message it to me, or you can yeah, I have like a little Discord server. I mean, there's only like 10 people in it. You're more than welcome to join it too, so message it to me on Discord. So okay, if nums is greater than mid, nums mid is greater. So if we calculate our midpoint, right, we're gonna get here. Well, I mean, I posted the link on the chat and it didn't work. Oh shit, I didn't see that, bro. I don't. Yeah, the link's definitely not here. I don't know. Maybe you might have to message it to me on Discord. I'm not sure. Okay, so if num's mid, right? So if our num's right, okay, our num's right is going to be here. So our num's mid, if our num's mid is greater than our num's right, then wishing you all the best in your job search and future endeavors. I'm from UK, so it's almost midnight. I'll catch you later. See you later, Shuby, dude. Thanks for stopping by, man, and appreciate the nice message, bro. Thank you, dude. What do we want to do here? If our num's mid is greater than our num's right, and our num's right's always going to be over here. You should just learn CPP by doing leetcode problems. That's how I learned CPP. Yeah, I know, dude. I should. I just I've been doing leetcode problems in Python, bro, for like 6 months, dude, and it I know like all the built-in functions. I know everything in my head, and it's like so frustrating sometimes. Like, I want to know how to do something, and I do it this specific way, and it's like I fucking don't know how to do it in C++. Just like drives me insane, and it's like pretty much googling everything while I'm looking. So okay, so we get our mid value. Our num's mid is greater than right, so no pain, no gain, dude. That's the way to think about it, bro. That is true. That is true. Now I sound like a little bitch, dude. Yeah, so we calculate our midpoint, right? When we get here, we see that it's greater than our num's right. So would we want to move our left pointer? Or would we want to move our left pointer to here? That's what I feel like a normal binary search would do. Alright, I'll just look up a binary search. I think that's what a normal binary search does, I'm pretty sure, but maybe we have to... If num's mid is greater than value, middle -1. High is equal to middle -1. I feel like we'd probably... Free middle is greater than value. What is value in this case over here? I'm just looking at this thing right here. When we think about binary search, right, find the mid value. Where do we want to move it in normal binary search? We'd want to move it. Maybe I need to get something up. Just think about this properly. Right, if we had a sorted array of numbers, okay, binary search, we'd have our left here and our right here, and we'd have our mid. I'll post the meme on Discord. Sounds good. I'll take a look at it right after this, bro. We find our mid value. We would check, well, if our mid value if our mid value is I guess we'd be looking for something. We'd have some sort of val, right? Like if we were looking for like 3 or something. You know, if our mid value, let's say our mid value is like, say it's 4, right? If our mid value is greater than 4, if our mid value is less than 4, right, which is what it is, right, because we're looking at 3, we'd probably want to move our left pointer to here, right? Oh, sorry, our left pointer not to mid. We go left plus 1, so we'd go left and then right, right? And then we'd run it again, and we'd check, well, we'd find the minimum of this, at the midpoint of this, which I think would probably be this element. I'm not really 100% sure. The point is we're trying to think about where we'd move this, right? So our left would go here. So in this case here, if our nums mid is greater than nums right, I feel like we'd still have to move our left closer, right? Because we're looking at 5 here. And we don't have our pivot point, right? So maybe we'd have to still move our left pointer. Left is equal to mid plus 1, right? If not, right, if our nums mid. Okay, now, so if our midpoint that we're looking at now, right? So now our left point's here, right? We do, our left is 0, 1, 2, 3, and our right is 7. Divide by 2. This should be our midpoint 1, right? So if our midpoint now is less than that, then maybe that's our value, right? Maybe we go like right is equal to mid, maybe? Move our right pointer? I don't know. And we would return our right. I don't know, bro. I have literally no idea. I know it's some sort of oh my god, we're not even increasing anything. Wait, our mid. Time limit exceeded. Maybe we get rid of the equals then. Oh, so we while left is less than right, while I don't know, dude. I'm gonna keep watching this video.
Now we have to ask ourselves, okay, you know, this could have been the result, but now we don't want to, you know, look at this value again. So the question becomes, are we going to search to the left or are we going to search to the right? Where are we going to find the minimum value? Where are we going to find a value that's even smaller than 5? Well, first consider this. Since we rotated the array, we have 2 portions of the array that are sorted, right? We have this portion of the array that's sorted, the left portion, right? And we have the right sorted portion of the array, which is also sorted. So the question is for us, with this middle pointer, at this value 5, are we currently in the left sorted portion or are we currently in the right sorted portion? Now, if we are in the left sorted portion of the array, don't we want to search the right sorted portion? Reason being, if we rotated the array, the left portion is always going to have values that are greater than every value in the right sorted portion, right? Because when we rotate, right, suppose an array like this, we're taking the rightmost value, the largest value, and putting it over here, right? So we're taking larger values, putting them on the left side, right? So therefore the values on the right are going to be smaller now. So that's why it's always going to be that way. So if our middle pointer is currently in a value that's in the left sorted portion, then we want to search the right sorted portion because it has smaller values in it, right? So how can we know if we are in the left sorted portion? Well, Like I said, every value in the right sorted portion is going to be smaller than every value in the left sorted portion. So one thing we can check is if the current middle value is greater than or equal to the value all the way at the left of our thing, right? Because the left value is going to be the smallest value. If the middle value is greater than or equal to the leftmost value, that means this middle value is a part of this left sorted portion.
So we're missing that here. It has to be equal to here.
Right? In which case we want to search to the right. Now, if our middle pointer, suppose in this case we can see 5 is greater than or equal to 3. The reason we're doing greater than or equal is technically this middle pointer could actually be at the left position as well. That's one edge case. And in that case, we would also, you know, this would be the left sorted portion. But suppose our middle pointer, instead of being at 5, was actually over here. It was at 1. What would our condition evaluate to then? Nums of middle would be 1. Is that greater than or equal to the left value, which is 3? It's not, right? Because the values in this right sorted portion are going to be smaller than the left sorted portion, in which case this would evaluate to false, right? If it's false, that means, you know, if we're at a value that's in the right sorted portion, then we want to search to the left, right? Because in this case, the right, if our middle was at this, it makes sense that, okay, you know, all the values to the right of it are going to be greater.
Do you have a side hustle that you've been playing around with and thinking about starting but don't really know how to? Well,
so then we want to search to the left. But obviously these values are also...
Yeah, you're right. We do... right is equal to mid. Mid
greater, but that kind of doesn't illustrate the point, because what if our middle pointer was over here, right? Maybe we had some values over here. You know, this is where our middle pointer is. We see 2. Okay, 2 could have been the minimum. Then we want to search to the left because we want to find even smaller values. Particularly, we would want to find this 1 that happens to be smaller, because we don't know where the pivot is. The pivot could be here, the pivot could be here, it could be anywhere. We just know we have to look to the left if we want to find smaller elements. If our middle pointer happens to be in the right sorted portion, then we want to search to the left. If our middle pointer is in the left sorted portion, then we want to search to the right. And I just showed you the condition we can use to detect that. So now I'm going to run through the example and it'll probably make more sense. And by the way, the algorithm I'm describing only works on a rotated sorted array. If we ever got to a point where let's say our right pointer was over here, meaning that, you know, this is our entire search pointer, now we're never example, and then we would stop the entire binary search. Okay, so now let's run through the example. These are the conditions that I talked about that we're going to be using. So our middle pointer is here. Let's check so, you know, we checked that this might be the minimum. Now we're never going to look at this again. So now we're going to check, is this value greater than the value all the way to the left? Yes, it is. So we're going to search right. Since we're searching right, that means we're never going to search these values again. So we can cross them out. We're going to take our left pointer and
so we did that.
Shift it to mid plus 1. So our left pointer is now going to be over here. This is our new search range.
It must do the same thing,
as you can see, this portion of the array is already in sorted order, right? How do we know that? Because the value at our right pointer is greater than the value at our left pointer. So that means that the array is entirely sorted, and then we can just take the leftmost value here, which is 1, see if it's smaller than our current result. Yes, it is. So then we can return 1 in this case. Now, just to kind of illustrate the opposite case, arbitrarily, I'm just going to say our middle pointer is actually going to be over here for some random reason. Let's just see how our binary search would work in that case. Well, we would take this middle value, say that it might be our result. So our result is going to initially be 1. And then we're going to run through these conditions. Is the middle value greater than or equal to the leftmost value? It's not. So we execute the else case, which basically means we're searching left, right? So we're going to take... you know, this is not going to be considered again. We're going to take our right pointer, set it to mid minus 1. So our right pointer is going to be over here.
I feel like this is just Very similar to a normal
and we're
one.
going to cross out 2 because it's never going to be
Binary
searched,
search
right? Because
approach.
we shifted our pointer. This is our new search range. Once again, you can see that this range is sorted. Basically, the left value is smaller than the right value. So this is already sorted. We can take the leftmost value over here, see is this smaller than our current result? It's not, so our result stays the same, and we don't have to search this entire portion because it's all set it to mid. The right
Nums left is less than nums right. Okay, so we did this one right. But if nums left is less than nums right, res is equal to min, res nums left. But we're not even moving anything.
sorted quickly search the entire array.
That's probably actually smart to do. Num 0 here. Oh, whoops. Right here. Replace this with num 0. Calculate our mid. Check here. So technically we did that right. We'll leave the else. Right mid -1. If nums m is greater than or equal to nums l, is it not just all integer nums unique? So nums m is greater than or equal to nums right. Oh, you did nums left. Left is equal to mid +1. Keep it up, buddy. Thank you, bro. Thank you, Sams. Appreciate that. Thank you, guys. Why does he check this first, though? If nums length is less than nums right, res is equal to min, break. So this must be when you when we know we've found something, or we know that we've found our minimum somehow, but I have to take a look at that again. So let's move this down. Up here he checks if nums left is less than nums right. Oh, whoops. What do we do here? We would update our res. Res is equal to the min of our res and our nums left. Then we break. Otherwise, we calculate our mid. We loop through. We check if nums mid is greater than or equal to nums left. If it is, right is equal to -1. And then we'd want to return our res, obviously. Can't access res. What do I have it as? Min num. Just switch it to res. Okay. Let's go through and review this again. Just to make sure I understand what's going on. Okay. Let's grab a little bit of a longer example. I think this one's fine. We got 0 here. That works perfect. Okay. We start our left. We got our right. Oh, whoops. Let's actually just draw our array. What is it? 4. Should we do this a little higher? 4. 4, 5, 6, 7, 0, 1. Let's make it a little bit more spread out. 5, 6, 7, 0, 1, and 2. Let's make this look a little A little better. Okay, right. So we start off with our left here. Start with our right. Okay, we calculate our mid. Oh no, we check first. Check, well, if nums left is less than nums right. So we actually check the value, right? Let's make our res. So we start off, our res is 4. Right? We check, okay, if our nums left is less than our nums right, which it's not, so we don't break, right? Calculate our mid. So left plus right, so 0 plus 0, 1, 2, 3, 4, 5, 6. 0 plus 6 is 6, divided by 2 is 3. 0, 1, 2, 3. So this is our midpoint here. Right? Please, can I tell you Solan? I can tell you solution. I already got the solution, bro, but I mean you're more than welcome to say it if you want. I really don't mind. I've got the solution here, but I'm just kind of running through it, doing a little dry run. So, but yeah, you can if you want, dude. Okay, so we calculate our mid. We check, okay, if our nums mid is greater than or equal to our nums left, right? So if nums mid is greater than our nums left, which it is, then we increase our left by 1, right? And we knew that. Okay, so we get rid of this left here. Okay, scribble that out. We move our left here, right? Another way. Yeah, sure, bro. I mean, you can mention it, yeah. What are you thinking, dude? Anyway, so we go to our next iteration, right? So we check, okay, well, if our nums left is less than nums right, which it is, we're going to return a break. So we make this our res. We return a break. We return 0. Okay, well, that solution kind of sucked. There was only 2 iterations, so that was kind of terrible, but okay. That's terrible, man, dude. They can't provide any better test cases, dude. Like, it's crazy, bro. Like, 5, 1, 2. Let's quickly go through this one. Just want to make sure I understand. A little bit of a modified binary search, but I guess that's what all kind of binary search problems are, right? They're all just like different modifications, but I find binary search tough, like thinking about it, other than just like the basic way. So really what we're doing here is just splitting these arrays up like this. Separate arrays. Okay, so let's get our left here. So we got our left and our right, and our res down here is currently 3. Okay, so we take our midpoint. Right, left plus right, so 0 plus 0, plus 0, 1, 2, 3, 4, right? So we get 2, so 0, 1, 2, this is our midpoint, right? This is our midpoint, okay? So we jump down here and we check, okay, well, if our nums mid is greater than nums left, which it is, we'd make this our mid here, right? Oh, sorry, this would be our left, my bad, sorry. Not our mid. Our left moves here, right? We go to our next iteration. We check, okay, well, if nums left is less than nums right, which it is, we return this. Okay. Return again. We'd set our res and return it as 1. So I'm thinking if our nums mid is greater than or equal to left, so if our nums mid. So what about if our... Man, couldn't have provided any better test cases, but that's whatever, like. But is it always a case where if it's greater than this one, then we always return our left? Our left is here. Why not focus on dev instead of DSA? I'm about to, bro. I'm about to. I just try and do it. I still do other stuff. I just kind of do leetcode on stream. Well, that's kind of what I've been doing, but just find the maximum number with code, and when you found the maximum number, just add 1 in its position value, you will get the answer. Yeah, but it wants you to do it on log n time, bro. That's why it's a binary search problem. I know you can do it in other ways. Trust me. You know, I know you could do stuff like that, but I was just trying to do it using binary search. So that was the what's it called, constraints or whatever. But yeah, Dipan. Sorry, I was saying your name, Dipanshu. Yeah, I do work on my own stuff outside of the videos. I just try to do a little bit of DSA, but yeah. I feel like it can be beneficial, yeah, but it's log in that way. Okay, so I got something wrong here. If left is less than or equal to right, we break. So what are we missing here? This test case here. We got 2, 1. We would start here. Get our midpoint, which would be 1. This would be our midpoint, right? So if our midpoint if nums mid is greater than or equal to nums left, we would move our left to here. So we move our left to here, and then we would go through again, and we do 0, we go back here, expected 1. I'm not sure, dude. What is our issue? Oh, we're not updating our res. That's why. How did I not see that? Nums mid. We need to update our res. Okay. Hopefully that's smooth. There we go. Okay. Sounds good. Let's get some C#, dude. Okay, let's actually take a look at your meme. Let's take a look at your meme, bro. Int. This is the pointer to the int, and then that pointer to the pointer pointing to the pointer. Nice, bro. I love the meme, dude. Sick. That's funny. Good stuff, bro. I like that meme, dude. That was good. Okay. So what do we want to make? We want to make a linked list template. The following methods. Gotta get rid of all this crap. That's all you need to know. That is true, bro. That is true. To figure out what I have to do for this again. Okay. Add a few things to this, dude. So what part are you stuck on? I'm kind of just learning, just to begin with. I'm working with a linked list problem. I'm just going to write out what I have to do in the problem because I kind of forgot. So jeez. Thinking Python, dude. We're implementing a generic linked list. We need oh, it's a uni assignment? No, dude, it's not a uni assignment. My buddy told me to do this. Told me to think about it because it's got pointers. I struggle with thinking about pointers and stuff like that. So, just told me to do implement a generic linked list. It's not a uni assignment though. It's just something I'm doing just to learn. So what do we gotta do here? We gotta define the class, make some constructor, make constructor, and deconstructor. What's up, Naveen, bro? How you doing? Deconstructor. We make the insertion methods. Removal. Make removal methods. Then retrieval methods. And some sort of display. Okay, let's check back in Discord. Okay. Many type. Okay. Will you do a deep copy and paste of the past value? I don't know. I think what I'm gonna do right now is just build the linked list class and then go from there. Just kind of getting all my stuff together. Hang on. Geez, so what is a template in C++, dude? I literally have no idea. What is template in C++? Oh, feature that enables writing generic, reusable code, functions, classes, next. Okay. Alright, I understand. Okay. I was a little confused what that was, but okay. Okay, so we got to define the class first, right? So let's define a linked list class. We can have, I don't know how here you can have what, private. You can have public things, right? Let's take a look at this over here. This shit's so confusing, dude. How do we even do a constructor? So constructor. We can reverse the linked list. We can reverse the linked list, bro. I've already done that, but I'm not gonna reverse the linked list here. I'm just trying to figure out the syntax, dude. C++ and how everything works, because I have no idea. It's like my first couple days ever doing it, so. If we were to create a new linked list object, what would we want to do? Well, So the way I understand templates is, let's say you want to define a add function. If you do, I think that's meant to be add. If you do trad C++, you will have to implement add underscore int, add underscore float, add underscore 64. But with templates, you define one function template, TA, TB, return A plus B. Okay. I'm working on Java, so reverse of linked list is possible. That is true. That is true, Naveen. But I'm just trying to implement just like a linked list class. That's really, I'm not trying to reverse it. I just got a mid to UIUC for CS transfer. Should I take it or wait for UC Berkeley? Dude, I got no idea, bro. Yeah, bro. I don't know. I live in Illinois, so I'm just gonna say fucking, you know, go to Champaign. But I don't know, dude. Whatever you want to do, bro. I'm sure you get a similar experience wherever you go. So, your mic is tripping up. Oh shit! Hang on. Is that better, or is that better, Galactic? Or so if we were to define a linked list, we probably need to define a list node, right? A list node of type T. What is this? This would be probably pointer, right? List node pointer. Pointer, wait, no, pointer doesn't go there. Pointer goes here. We'd probably want like a int value, right? Or would it be T value? I don't know. Just go to the uni where all the kids of CEOs go to make a ton of friends, and you won't have to worry about not finding a job in the current market. Yeah, bro, that's the way to do it, dude. Go to UIUC, bro. Go Fighting Illinois, dude. I live like very close to there, so I went to Eastern Illinois, which is about an hour south of there. So I was always up in Champaign all the time. It was fun. Okay, so we define the linked list class. We'd want to get a head and a value, right? Of type T, the generic. How do we implement a constructor? How do we implement constructor C++? Okay. How do we implement deconstructor C++? How does a deconstructor work? I don't know. Shit, dude. What is the syntax? Your current linked list will only support int as a value, though. Will only supports int as a value there. What? So you're saying I use type T or generic type or whatever? I just put int just because, why not? But how would I even put a generic type here, dude? I've got no idea. Or is it like T? Oh, there we go. Okay, T value. That's cool, dude. Let's go, Albert. YouTube recommendation system is sick. I just started the same journey 2 days ago, literally coding every day, mostly machine learning, deep learning stuff till I get a job. Yeah, bro. Thank you. Yeah, Galactic T value. Thank you for that, bro. Yeah, dude. Good luck with that, Albert, dude. That sounds awesome, dude. Okay. Okay. So this is our constructor. This would be our deconstructor, right? Just trying to get the syntax going here. Squiggly line, linked list, deconstructor. All the best for your future endeavors. Thank you, bro. Appreciate it. Thank you, guys. Alright, so what would we have to do in a constructor? In a deconstructor, right? Really? In a deconstructor, we're cleaning up, right? So remove everything. So to do that, probably have some sort of while loop, right? But if we were constructing the object, what do we want it? Are devs really getting paid, mate? I don't know, dude. Depends where you work, bro. No idea. Depends where you, yeah, I don't know. Depends where you work, I guess, dude. We initialize, right? So we come here. We do, head. How do we initialize it? Equal to null pointer? Shit, dude, you were chaining linked list classes, not linked list nodes. I thought we'd be creating. We have a list node here from this struct. Type list, a list node with type generic, pointer, head, t value. Initializing the linked list. Oh, never mind. You do have a node struct. Yeah. Sorry. Yeah, my bad, dude. You wrote, yeah. Never mind, I'm tripping. Okay. Alright. Sounds good, bro. Sounds good. So we have our head here, but how do we do this? Are we assigning it like this, bro? Or is it like, how does this... I don't even know, dude. Maybe... null pointer? Or is it like this, dude? I don't know. You don't need to store a value in the base class thing because you will store that in node struct. Okay. Okay, I'll leave this for now. We want, what do we want? Define the class, constructor, insertion methods. What are the methods? Hang on, I have to read the thing. Push front, add element at the beginning. So we need a void pushback of t value. We need a void push front t value. Why wasting time in coding when AI can do everything on its own? Yeah, dude. I mean, it can. I can ask GPT to do it all for me, but or whatever. But I don't know. It's kind of fun, dude. I just enjoy programming, bro. That's really all it is. So I just enjoy the thinking and everything. So that's it, bro. Zoom in the code, can't see anything. Is this better, bro? Member initializer list. What is a member initializer list? Increase font sizes, yeah. Good luck, brother. Thank you, dude. Do you have to follow function naming conventions? I thought pushback, push front were for queues and arrays. Dude, I have no idea what they're for, bro. I don't know the naming convention C++. Maybe it's meant to be like this. You saying it's meant to be like this, or I don't know, dude. I got no idea. Slightly less efficient. Okay, so I think here, bro, you meant to do head null pointer value value 0. I don't know. Apparently this is meant to go like this, dude. This is member initialization. Never heard of this. So we remove this. No. For linked lists, I usually do insert node t value because you're inserting into a chain of nodes. Yeah, yeah, insert node, yeah, t value. Yeah, my buddy just sent me a like a little description. I just copied the method from there. It's like this in the thing. I'm sure there probably is naming conventions. I'm just not really 100% sure about it. I don't know. But yeah. So I'll push front, right? So yeah, I'm gonna do this. I'm gonna work on this a little later. This is a little boring to think about, to be honest. I don't really want to. I think I'm gonna try and do a leetcode problem in C++ instead, just to get kind of familiar with the syntax, because I feel like me just googling up stuff is pretty boring. So, let's take a look at something. Actually, let's do a linked list problem. You know, why not? We were just looking at a linked list. You can actually leave the constructor empty for a linked list. I thought I was just initializing the node though, because didn't I pass in that node as like a private variable? So wouldn't I have to initialize that somehow? I don't know. Let's do a linked list. Oh, go back to the study plan. Kind of get a little bit of a feel of linked lists. Where the hell? Okay. Add two numbers. Let's take a look at this. We're given two non-empty linked lists representing two non-negative integers. Digits stored in reverse order, and each of their nodes contain a single digit. Add two numbers and return the sum as a linked list. Okay, so we're just adding these two. Okay. Are they usually the same length? No. Okay. So we do curves. Oh shit, this is Python. Fuck. Oh, that is true. That is true. That is true. Okay, so let's think about this. My idea for this is, right, we create a while loop, right? We loop through, keeping track of 2, 4, 3, 5, 6, 4. Right, keeping track of 2 pointers, L1, L2, right? We keep looping, right? Moving at the same time, loop, 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 loop. Right, if one of them goes out of bounds, I've done a bunch of linked list problems, bro. I know how it works, bro. I was just kind of, I need to spend a lot of time on that. I'm confused with the syntax, and I got to spend a lot of time on my own to be able to implement something like that. I know what a linked list is. I know how it works, like, fundamentally. So, we keep looping. When we get past here, then maybe we can have some sort of flag, and then just add the remainder of the problems, right? What do they do here? They go 8 99001. 1, 2, 3, 4, 5, 6, 7. So representing two non-negative integers, the digits are stored in reverse order, and each of their nodes contain a single digit. Add two numbers and return the sum as a linked list. Yes, I'm talking about C++ syntax. Oh, okay. Man, it's so frustrating, bro. Like Check if the next node is a null pointer. If it's a null pointer, you know that you're at the last node. Okay. This node pointer dummy is equal to new list node. What are we returning here? Okay, so we're returning a list node. Right? Or are we returning an array, dude? What is going on here? Python 3. No, we're returning a list node. That's so weird because it looks like it's an array here. That's C#. Oh, is this C#? Oh, whoops, my bad. C++. This node. This node pointer dummy is equal to new list node. Oh, bro. It's so hot, bro. I'm literally sweating balls in here, dude. I think I'm gonna call. I'm gonna come back to this. I'll be back tomorrow. I'm gonna keep working on the C++ stuff, but it's hot in here. And I'm gonna make some dinner, so I'm gonna take a break. I've been doing this for about a couple hours now, so I'll be back. So thank you guys for watching, bro. I'll see you guys tomorrow. Oops, someone's calling me. I'll see you guys tomorrow. Thank you guys for watching. Thanks for the nice comments. I'm gonna keep working on this stuff, and I'll be back at it tomorrow. So appreciate it, guys.